April 4th, 1975, two men ruined my life. Their names were Bill Gates and Paul Allen. You might have heard of them. They co-founded a little company called Microsoft. And I hear you saying, well, Matthew, what could you possibly have against Microsoft? And I'll tell you, it's SharePoint. At the very start of my career, I was working for a Microsoft partner on a project for local government, and SharePoint was really at the center of that project, made use of a lot of the Microsoft stack, SharePoint, Microsoft Dynamics, CRM, Windows Workflow, .NET, C#. One of the guys from Flipdays mentioned IIS earlier, and I nearly fell off my chair because I'd forgotten about that monster too. And I said to myself at the time, I will never work with the Microsoft tech stack again. I'm going to walk over here because I'll get sunburned standing in the sun. I will never work with the Microsoft tech stack ever again. Fast forward then to last year. We had a new project at Instil, as we always tend to do. It was a health insurance platform in the States for a startup. And I said last year at Serverless Days Belfast that it's a tense time. I think it's probably the most stressful time whenever you're starting a new project, because essentially your fate is going to be decided for the next 12 months, 2 years or whatever. And we're having that typical conversation with the director of engineering about what decisions have been made in terms of architecture and technology choices. And he started to rattle off a few things. So he said, we're going to use AWS. And I said, yes, that's fantastic. Love using AWS. He said, we're going to use a serverless first approach. And I said, thank goodness, I don't need to explain what serverless first is anymore. We can just get going. And he said, and we're going to use .NET. And I said, yes, absolutely. Hold on a second. Did you just say .NET? No, you see, .NET's made by Microsoft. Microsoft made SharePoint. And this cannot be happening in my life. But he was adamant. He said, no, we're going to, he's like, I'm serious. We're going to use .NET with AWS. His argument was that for their domain, the health insurance industry in the States, they could find .NET developers with the necessary domain knowledge in the health insurance industry. So I couldn't really argue with his point, but sometimes when you're doing some software consulting, that's just the way it is. The right choice for the customer might not necessarily align with what you perceive to be the right choice or your preferred choice. And really, it would be foolish for us to turn down a project because they were using .NET. It would be a wasted opportunity. And today we're going to ask the question, can you find joy in serverless.net? My name is Matthew Wilson. I'm husband to Rebecca, father to Joy Tabitha. I'm a distinguished engineer at Instil and an AWS community builder and user group leader here in Belfast. And we're going to look at 4 things. We're going to set the stage. We're going to look at safety without sacrificing performance. We're going to look at the simplicity of the ecosystem and how you can soften the blow with generative AI. And we might just ask another question, has Matthew forgiven Microsoft after all these painful years? So let's set the stage. Like I said, this is a health insurance platform for a startup in the States. They had nothing built. This is totally from scratch. And at a very high level, our architecture was this. We were tasked with building 2 things. We had a serverless data lake. Again, AWS. It was built on top of S3, AWS Glue, and Lambda, getting that separation of storage and compute. And an important thing to note about the data lake is this was our integration point in the system. We were pulling data from a lot of different vendors, and that was all streaming into our data lake and going through a medallion architecture from bronze, silver to gold, or raw distilled to conformed. And AWS Glue is at the center of getting that data from its raw state into its conformed state. Obviously, Python was the language of choice for the data engineers because it just totally dominates that stack. And when we get new events, or something new comes into our data lake, like a new member, there's an event-driven process which pushes notifications into this operational layer. And this is where we have our serverless backend using a stack that at Instil we're very familiar with, AppSync, Lambda, DynamoDB, obviously some other things in there as well, but they're the main things we used. And any other day at Instil, this would have been a TypeScript project. And we have a lot of TypeScript experience. Everybody loves writing TypeScript. You get acceptable performance. For our use case here, it's serving up. And we were building an API that was going to be used by web and mobile clients. And you get to use one programming language across the entire stack. We're full stack engineers. having one language for front-end, back-end, and your infrastructure as code with CDK is really attractive to us because engineers can get good at one language and not have to context switch when they're trying to do different things. But unfortunately, we were stuck with using .NET in this case. And when you are, I obviously tried to change the customer's mind, okay? Like, I didn't just, take this decision lightly. I tried to make the argument that when you're using .NET with serverless and AWS, the main downside here is to do with performance. I'm not sure if you're familiar with this repository, the Lambda perf repo. Every day, it benchmarks all of the various runtimes for AWS Lambda and publishes a nice dashboard you can go look at and see the various different stats for the Lambda runtimes. And on the screen, we just have two screenshots. Top one is Node.js, and the bottom one is for .NET 8. And you can see on the very left-hand side, we have the cold start time. So for Node.js, we have 160 milliseconds. For .NET 8, 246. So a significant difference there in cold starts. In the middle, we have memory usage. Memory usage is, there's very little difference there, a couple of megabytes. Not going to worry about that too much. And then we have the average function duration. So this is significantly worse. This is how long it takes to perform a simple hello world program. 12 milliseconds in Node.js, 677 milliseconds for .NET 8. And that reason alone, I think, rules .NET 8 out of many serverless projects. The performance that it gives is just unacceptable for a lot of different use cases. And with any technology choice, nothing's perfect. I'm not here to say that Node.js is in some way greater than .NET 8 because JavaScript and TypeScript have its flaws as well. And there's one issue that I've seen catch engineers out multiple times is around type safety with TypeScript and then JavaScript. If you're not familiar with this, TypeScript is transpiled into JavaScript. And as part of that process, all of the nice types that you have defined in your TypeScript code, they're gone. That process is known as type erasure. And when your TypeScript program is running in the Node.js runtime on Lambda, it's just running JavaScript at that stage. Types are gone. All of your nice union types that you've defined, all of your nice interfaces, all of the utility types that you've used from TypeScript, they are non-existent. And that can lead to a number of bugs. And an experienced TypeScript engineer will know this, but a junior engineer might not. And I've seen it catch out a few developers. And a simple example here is you've defined a person interface. They have a name, which is a string, and an age, which is a number. And you go and fetch some data to do with this person from an API. You take your JSON string and parse it. But the issue here is that their age is coming into you as a string. If somebody tries to increment that age, that'll print 301. There should be a 1 here. It should say not 31. And this is obviously very simplistic, but this is something that has caught people who are experienced and inexperienced because you don't have any control over this data here. This is coming from an external source, and you have to validate it in some way. Now, if you are using TypeScript and you are having problems like this, then a way to solve this is to use Zod. Zod is an external library that will give you some kind of type validation and more with TypeScript, and it's also built into the PowerTools for Lambda project as well with JavaScript. But it was really refreshing for us using C# to have bugs like this just eliminated because they simply can't happen. They won't be allowed to happen because you have runtime type safety. It's much stricter in that regard, and it was really, really nice for us to be able to use it. But that question still remains. The safety that you get with a language like C# and .NET really isn't worth it if you're going to sacrifice performance. There's no point in having a very, very safe API if it's barely usable for the end user. So with .NET, how can we get our safety and our performance at the same time? And with .NET 8, there was a new feature that was released called Ahead of Time Compilation, or AOT. And really what happens is if you're using AOT with .NET, your code is compiled ahead of time into native machine code. And that is what you then publish in the Lambda, and Lambda will execute that instead. If you're not using that, then what you're using is JIT, or just-in-time compilation. and that means that your code is being compiled when it's needed at runtime. The benefit of ahead-of-time compilation is, firstly, startup times. So it will be significantly faster to start up than a JIT program. And it uses less memory because you're not having to load that JIT compiler into memory to use it. And like we saw with the benchmarks for Lambda, startup times and memory usage are critical things that you need to optimize in a compute environment like Lambda. You could really say that AOT and Lambda were designed for each other. If we bring back our performance charts then and look at the top, for a .NET 8 AOT Lambda function, nearly half the cold start time of Node.js, never mind what .NET 8's doing. Memory usage is significantly less, 22 megabytes versus around 70 for these two. And in terms of average duration, we're getting comparable performance to Node.js. That was actually quite surprising for me, to be able to use a beefier language like C#, let's say, but get acceptable performance levels. One thing to note, recently, this cold start time here, right now our cold starts are free on AWS, but from the 1st of August this year, I believe, we will start to be billed for that cold start duration. So it's in our best interest to minimize the cold start time as much as possible. And Luciano's sitting there looking at me saying, just use Rust. But this wasn't my choice, okay? But what's the catch? Right? What's the catch? And there's two, big catches, I think, with AOT and .NET. First of all, there's no cross-architecture support. AOT functions need to be compiled on the processor architecture and operating system that they're going to run on. So to give you an example, if you want to use a Graviton Lambda function, which is using ARM, you need to compile that on an ARM processor. In Amazon Linux 2023, which is the operating system that is used in the Lambda runtime. For us, we're using M-based Macs, which is fine because they're ARM CPU, so we can, we get past the hurdle of a processor architecture issue. For the operating system, the teams at AWS have released an extension for the .NET CLI that will pull down a Docker image, which is Amazon Linux 2023. Copy all of your code into that, compile it, output it as a zip file, and then you can use something like Terraform just to deploy that into the cloud. So this really isn't, no cross-architecture support is a problem that's easy to solve. We had one issue with an external contractor who, bless his soul, was having to use a Windows machine with an Intel CPU. And we had to, really what he was doing when he deployed was deploying using a processor architecture that wasn't the same that's in production. And that might lead to probably going to be okay, but could lead to some bugs down the line. This one here is actually the worst part of all around serialization. And you say, well, serialization is a funny thing to get caught up on, but the way serialization works in .NET, in the olden days, let's say, is that it used reflection-based serialization, where you would use reflection to look at the metadata of an object. So let's say we had our person object with a name and an age. You use reflection to work out that this object has got a name field and an age field, and that's how you then take your JSON string and stick it into that object. Reflection is gone with AOT because it's all trimmed away, so it actually doesn't work anymore. You have to use what's known as source-generated serialization. Essentially, the code that is required to serialize and deserialize your objects is generated at the compilation step. It's all done ahead of time, and that's fine. If you're able to use source-generated serialization, then this really isn't an issue. But if you are using a lot of third-party SDKs, the .NET landscape is dominated by a library called Newtonsoft JSON. Newtonsoft JSON uses reflection. It's incompatible with AOT. Therefore, a lot of third-party libraries just don't work with an AOT Lambda function. So for us, we needed to use the Auth0 SDK, and we couldn't use it because it used Newtonsoft JSON. Now, at the very start of the talk, I talked about the data lake being our integration layer. That was a really good architectural decision because really, at our operational layer, we're consuming events and storing them in DynamoDB and doing very little calls out to third parties. So we don't have a huge dependency footprint, let's say. But in hindsight, the advice that I can give for this is if you're starting from scratch, AOT and .NET is probably the best default choice. If you, but you need to audit your dependencies. You need to look and see, well, what are we maybe going to talk with here, and see if there's anything that's going to catch you out around AOT. You obviously can use a mix of AOT functions on the request path and non-AOT functions for things like batch processing and stuff like that, where the latency isn't as critical. If that's not possible, then you could look at something like SnapStart, which will take a snapshot of preloaded, of that sort of just-in-time work that's already happened. You snapshot that, and then that's loaded back again during runtime. So that's another way to help with performance. And other than that, then you're going to have to just use Rust or something instead. But there's one thing that stood out for us as we were building this platform. And yes, we had to do our AOT compilation. We had to take care of source generators and serialization. The tooling that was provided by AWS really did a lot for us there. They had the necessary libraries to be able to use things like source generators. They had the necessary CLI extensions to be able to deploy the thing. And because of the constraints that we had, the constraints with AOT.NET, the limited options by using .NET in AWS, it actually led to simplicity rather than complexity, if that makes sense. And I think it's a fair point to make that if you're a .NET developer, you're going to tend to use Azure rather than using AWS. So AWS have had to do a lot of work to make it a seamless experience for you to use .NET in AWS. And I think that is true. I think in our experience, that's true. There's 3 things I want to point out. Like I said already, the tooling is excellent. Extensions for the .NET CLI. There's blueprints, so you can have blueprints in your IDE. We're using JetBrains Writer, but they'll work with Visual Studio as well. To scaffold out the necessary boilerplate to get your AOT function working, there's an open source project called the Mock Lambda Test Tool that allows you to invoke your .NET functions locally. And it's excellent, and we'll talk about that in our last point of the talk as well, because it became really useful for our team. Secondly, we were delighted that we could still use PowerTools. .NET support for PowerTools is relatively new, compared to Python and TypeScript. But for us, the consistent approach across projects is really valuable to us. We're taking engineers who would have worked on a TypeScript project with PowerTools, able to put them onto this project, and the way we tackle logging, metrics, tracing, batch processing, caching and loading of secrets, that's all taken care of by the PowerTools library. And it really gives us best practices out of the box and a consistent approach across projects. And most importantly, the team worked really hard to get native AOT support in there. When we started the project, they were working on it, and we sort of took a little bit of a risk that we would use PowerTools in the hope that they would get there in time for us going live. And we managed to make it with a few months to spare, which is amazing. Thirdly, then, ASP.NET. You can still use ASP.NET with your .NET Lambda functions using this package, ASP.NET Core Server. And that lets you run an entire ASP.NET API in a single Lambda function. And that's a really nice pattern. I think we need to talk about a little bit more. This idea of a single function API. So in an example here, we have an API for manipulating users. That should hit a single Lambda function, not 3 individual Lambda functions. And the benefits to this are, first of all, it's simpler. Rather than having to look at your infrastructure as code to figure out how your API gateway is going to route requests to what Lambda function, it's all self-contained in the code itself. It's simpler in that regard. It's simpler in terms of being able to package and deploy as well. Rather than having 3 things to do to compile and deploy, you've just got 1. With something like AOT, that's important because the compilation step is slow. It's faster. If this is a busy API, this Lambda function is always going to be warm. It's always going to be busy. It's always going to be ready to serve requests, and you'll see less cold starts as well. And because you're using something like ASP.NET, you have local support. You can just hit play in your IDE. It'll start that ASP.NET server, and you can hit it with Postman or whatever you want as well, which is a really nice pattern. You can still do this without using ASP.NET. There's an open source project called the Lambda Web Adapter, And if you say you wanted to run an Express server or a Flask server inside a single Lambda function, this library will enable you to do that. I used to be of the opinion, I think at my very first serverless days talk, I talked about how we should bring developers to the cloud instead of bringing the cloud to the developer. But I think we need a mix. And libraries like this, and having that single function design really helps you to run things locally, test that they work, and then deploy into the cloud when you want to test it a little bit further. And that's a really nice pattern that we get into as a team. So we sort of proved out that the technology was going to work. We had built out a few different microservices. We had deployed that into AWS and proven that the performance was of an acceptable level. But there was one thing that was really slowing us down as a team, and that was just around that whole development experience. We have to, if you think about making a change, you have to make a change, do an AOT compilation, deploy that using Terraform, and that's just going to slow a developer down. We wanted to get that really nice local experience, but still talk to remote services in AWS. And on a lot of projects I've been on, somebody always says something like this: "Wouldn't it be nice if?" And I think that "wouldn't it be nice if" is an opportunity to put generative AI to work. And what we were saying as a team was, wouldn't it be nice if we could run everything locally without manual configuration? And what I mean there is, at this point in the project, we had maybe 5 microservices. Each one was an individual Lambda function. And we wanted to be able to run all of them together by hitting play in Writer and be able to hit them using whatever tooling we wanted, whether that be Postman or that Mock Lambda Test Tool. But we didn't want to have to manually go and get our AWS, our access key ID and our secret, drop them into environment variables, and then have to do that all day. So instead, what we did was we asked Copilot to help us. We used GitHub Copilot at Instil, and I asked it to write me a bash script that would take our Terraform output, generate all of the necessary writer run configurations so that I could just hit play in my IDE and test it using the tooling that I had. And it did it, it worked, and the team has been using that with great success. And the point I'm trying to make here is that those wouldn't it be nice ifs is a good opportunity to start practicing working with generative AI. It's relatively low risk. That's not code that's going to ever reach production. It's just to help your engineers out and get that really nice local development experience and reduce that death by 1,000 cuts. So, is there joy in serverless.net? Have I forgiven Microsoft after all these years? Well, it pains me to say it, but yes, our team found joy in serverless.net. We got that safety without sacrificing performance. That's really important for an inexperienced team. Having as many guardrails as you can have for an inexperienced team is critical. There's a simplicity of the ecosystem. Less options actually sped up our development process. And really, the team really loved working with this tool set. And how you can soften the blow with generative AI. Solve simple tasks that you might have avoided due to time constraints. Don't suffer all these 1,000 cuts, and really enable your teams to be able to use their tooling in the most effective way. The important thing to learn from this experience for me is that really sometimes we focus on the wrong things. We focus on the code that we're going to write. We focus on the frameworks that we're going to use. But that's really not what's important in software engineering. In software engineering, what we should really care about is the artifact. We should care about the end result. We should care about what our users are actually going to be doing. And they don't care about serverless.net. They don't care about AOT. All they care is that they can submit a claim for their health insurance and get the care that they need. We should use the tools at our disposal to enable that and not let old biases get in the way. Thank you very much. If you want to connect with me on LinkedIn, you can, and I can chat with you after as well. Thank you.